I'm Phil, and you're watching The Joy of Electronics. In front of me here on the bench, I've got an Egnater Tweaker 15. By all accounts, a great little tube amp. The only problem is I bought this one non-functional. So when I first of all, figured I'd make a video just because I'm trying out one of the first steps of the repair that I've identified, and I'll just talk about how I found the amp and what I've done here, and then we'll replace some parts and see if it'll sort out the issue. So the description when I purchased this amp was it worked, and then there was a pop, and then it didn't work. Though it turned on, there was no sound. So when I opened up the cabinet and took the amp chassis out, one of the resistors was actually rolling around in the cabinet, and that was R28 right up here. Now R28 tested all right, tested within spec. It's a little brown, but tested fine. So I popped it back in, asked a couple people, looked at the schematic as to well, okay, first of all I popped it back in and turned the amp on, and I would get a kind of a hum through the speaker but no signal, and after about 30 seconds I could smell that something wasn't right, something was burning. So it had to be something else, obviously. Now, looking at the schematic and talking with some people, they suggested that I have a look at C29 here, which is I believe one of the filter caps. And sure enough, when I took C29 off, I'll show you what C29 looks like. One of the leads utterly destroyed. Positive lead utterly destroyed. The lead fell out when I took the capacitor out. Left a bunch of garbage on the board, which I've since cleaned up. So that was C29. So I thought I'd have a look at C30 because there was a little indication beside the capacitor that something wasn't right, and sure enough, C30, basically the same damage. I'm not sure what caused that. Maybe some event, maybe just bad caps. So normally I would just replace the caps that failed, but others who have worked on this amp, someone suggested actually that the debris from the failed capacitor might actually bridge the negative and positive terminals of the capacitor, and therefore you should cut the trace and mount the capacitors some other way to the appropriate spots. That seems like a lot of work and quite disruptive to the board itself, which I wasn't ready to take on at that point. And actually Bruce Egnater, the owner of the company, I would think, Egnater Amps, he's a great guy. He's active in some message boards and Facebook groups. He suggested replacing all of the filter caps, as well as just heavily cleaning the circuit board to ensure that there's no debris from the failed capacitors on the board. So I've cleaned as best I could these two spots with rubbing alcohol and a Q-tip, and using actually an X-Acto knife really gently to kind of scrape up some of the adhesive that's used as well, just to make them a little cleaner. And I'm not going to go against the maker of the amp, so I'm going to go ahead and replace all of the filter caps, because actually this board is pretty hard to get out of the chassis, and I don't want to have to take it out again very soon, at least. Hopefully we can get this working. So I've got replacements for this one, this one, this one, this one, this one. this one and this one, I think. So we're going to go ahead and take all of those out and replace them. And hopefully the amp will light up after that. Unfortunately, I did take a few of those out. I'm not sure if I took all of them out, but I took a few of them out just to see, because if they were failed or if there were any issues underneath, like the ones that did fail dramatically, and it turned out they were fine, so I put them back in. So I'm actually undoing my own work here, but that's how it goes sometimes. It's better in this case, I think, to listen to Bruce and go ahead and do what he suggested, which sometimes referred to as shotgunning, because you're replacing a whole bunch of parts, hoping that it makes a difference, hoping that you hit the target. Though, you know, if we've already had 2 capacitors fail on this amp in that pretty dramatic way, you know, there's a fair chance something else might go, or this batch of capacitors maybe all shared an issue. So we'll go ahead, start with the largest, and we'll swap them out one by one. I may go ahead and fast forward this on the video, because all we're doing at this point is desoldering, and that can be pretty tedious to do. I would think pretty tedious to watch as well, unless it goes super smooth. But with these big can capacitors, I'm not sure. I haven't done a whole lot of these, so we'll see if we can get this one out. That wasn't too bad. Now we'll see if its replacement fits in just as easy. We'll just double check the values. Here we've got 150 UF and 450 volts, and here we've got 150 UF, 450 volts. They look to be the same size, which is what I was hoping for. So here we go. Fits in really well, so that's good. Okay, one down. Got to be pretty careful when you're ordering these types of replacements. These ones are about $5 each, but more importantly, you got to get the physical size correct, or they're just not going to fit in the amp, or the amp is not going to close up the way it should once you've made the replacements. Okay, let's get back in here. Maybe that'll be enough. Seems pretty loose. These can capacitors have much larger leads than your little kind of through hole caps. There we go. 2 down. Did I leave enough? Maybe we'll be able to get the next replacement in with that. Let's see. Again, we've got 100 UF, 450 volts, and our replacement 100 UF, 450 volts. Careful to get the polarity right when we're putting them back. This one seems like I might have to make the holes on the board a bit bigger. Or at least make sure they're solder free. So let's hit them again. Yeah, I'm going to have to make these bigger. So you can see that the new one, although the same physical size, the terminals, the leads are quite a bit larger, kind of the snap-in version versus the through hole. So I think I'm going to have to drill out the mounting holes a little bit for this to fit in. So I just have to pause this, and then I'll find a something I can drill with. Okay, I've got my cordless drill here, and I've got a set of kind of small bits that you can pick up these types of sets on Amazon. Not that expensive. Just these small bits tend to break a lot, so it's good to have. Excuse me, that's the drill. Good to have some spares on hand. So obviously you want to be really careful when you're doing something like this, drilling through. Let's try to figure out which is the best way. It would be best from the top side here. Don't try to go slow and try not to lift anything, and I'll try to aim it down so as not to drop debris onto the circuit board, but maybe just into the chassis, and then I'll vacuum that out. Okay. Wasn't too bad. A couple little bits of debris. I'm not sure if that's going to do it though, we'll have to see. Alright. May have to go one size up, but we'll see. I don't want to force anything, and we got lots of space here. I think we got to go one size up. You know, I don't mind doing this type of drilling because the pads are pretty large here, and I'll just brush that off with my Bob Ross brush. Comes in handy. So we'll go a little larger. You know, better to step it up than to go too large on the first shot. So stages kind of stages kind of helps maintain stability on the board. You're only taking a bit of material off each time. Less chance of lifting the trace, I would think. Alright, I think that's going to be enough. Let's see. That's still, it's still fighting it. These are a lot bigger than I thought. That's too bad, but we'll get there. I could probably push it through, but we're gonna go again. We're gonna step it up. Go. I did look for these caps with the through-hole mount rather than the snap-in, but they weren't available from the retailer that I was ordering from. So here we are. Okay, there we go. Nice and snug. Lots of lead underneath. Let's clean that off a bit more. And solder that one in. Okay, 2 down. Now we've got the troublemakers there. So I actually ordered 2 slightly different sizes of these. We'll see which one's more appropriate. So that's the previous. And these are 47 UF, again at 450 volts. So that looks like a direct replacement. And we're at 47, 450 volts. So we'll go with these. And we can do both at once. It's plus, minus, minus. Okay, and one more. Okay. Solder these in and moving on. Try to get the glare off the board. There we go. That's pretty good. So these are the 2 troublesome replacements. Hopefully this is going to bring the magic back. Okay, the next one's a bit of a smaller one. Trying to see the value. I wrote the value down, but okay, that's 100 UF at 100 volts, I think is that one, and I believe I did get replacements for those. Just have to find them. 100 UF at 100 volts, so we do have a replacement. which are those leads? That's these two little leads here. We're back to kind of normal, more capacitor sizes that I'm used to, rather than those behemoths. Obviously, if you're working with tube amps, you want to make sure all the caps are discharged. This hasn't been powered up since I checked it the last time. The board hasn't been back in, so I know that these caps are all discharged. So there we go, 100 volts, 100 UF, and we've got pretty close, a little taller. I think that's going to be okay because we have that extra height. And this is 100, 100, 100. Again, making sure polarity is correct. Do I need to get some more solder out of there? No, we're good. One thing about this amp, I mentioned it was a bit difficult to get this board out. The spade connectors, whew, they were tight. I mean, which is great for making connections, but they were difficult to pull out. And of course, you don't want to put so much pressure that when they come off, you're smashing your hand or putting too much pressure on some other component. So yeah, bit of a balancing act there. Okay, next one is this one, which is 450 volts, 10 UF. I think I have a replacement for that as well. 450 volts, 450 volts, 10 UF. Hopefully our physical size is going to match. Volts, 10 UF. Alright, you can see there's still some fuzz left from when I cleaned this board with rubbing alcohol and Q-tip. I mean, Q-tips aren't necessarily the best because they can leave a little bit of fuzz behind, but just be careful to clean all that off. Alright, so we got our replacement. Just checking, we're looking for this one. Whoa, at these two leads here. Keep looking at desoldering stations. I should really get one, but for now it's just the sucker. If somebody can recommend a good desoldering station, then certainly do so in comments. Alright, I'm going to probably have to clean out more of this before I can put the new one in. But there we have it. 10 UF, 450 volts. We got our new one, 10 UF, 450 volts. Let's see if they'll slide in. Not quite. I kind of left a little too much solder in one of these. There we go. We'll just see about double checking the polarity. Yeah. Alright. Nice and snug. It's 1, 2, 3, 4, 5 down. This will be number 6. Got one more. And then we're done. far as recapping goes, once this board is out, it's been really smooth sailing. Knock on wood. Got one left, which is what are you? That's another 10 at 450. So those 10, 450. These are on tape, relatively sticky tape, but we got it. And then it's about finagling this board back into the chassis, because I'm figuring out where all these spade connectors go. I took some photos, and there's some photos online, but we'll see. I may have to look at the schematic to be sure of where all these. So we're doing this one now. Be sure where all these spade connectors go back in, because there are a lot of them, which again I kind of appreciate, because they're not just hardwired, but hopefully putting them on is easier than taking them off, which I would think it is, assuming I don't make any mistakes and have to put them on and take them off multiple times. Okay. And in you go. Nice and snug. These ones are really tight against the board. They're like right up there. I guess that helps with vibrations and stability. Doesn't leave a lot of room underneath. If they fail for whatever falls out of the failure, but there you have it. Okay. So that's the cap's done. I didn't replace these little ones. I don't think they're at as much risk. So now it's about getting this board back in. So I may just double check this against my photos to ensure that I've got everything, the polarity right. I mean, I checked them against the circuit board markings and tried my best to keep in mind which way they were oriented when I took them out. But I really don't want to be taking this board out again. So I'm just going to double check that, and then we'll get to putting the board back in. Okay, let's see. Double check the orientation. I think we're all good. So we're going to try to get this board back in. Now you can see why it's kind of tricky here. Do some acrobatics. It was very tight. Okay. First I tried to get it out without disconnecting everything. No dice. Well, I mean, I say everything, but there's a couple that could stay connected. But as you can see, getting it under all of these, all this wiring without having to snip all these cable ties. And when you snip the cable ties, you kind of lose the orientation, the bundlings of the wires, and you might have a harder time bending. Over there. You might have a harder time getting it back in at the same time. There we go. That's looking a bit better. Have to clear these pots, which is another hurdle. I may fast forward this so you don't have to suffer through it along with me. Gotta stand up to get a kind of a better angle on it. What do you think, that's outside or inside? I'm going to go with under. There's a mount there. Okay. This. Whew. There we go. I think that was over the hurdle. Come on up a bit. There we go. Oh, right. How's that? That's clear. Okay, now it's a matter of figuring out exactly what was where. These ones seem pretty clear. So why don't we put those in? Pretty clear seems like a terrible way to do this, but I mean, honestly, I'm not sure how else these would go. I don't think they fit any other way. So I mean, that's, I guess, positive. If I can definitively see that they only stretch one way. If I'd taken out the electrical ties, unbundled some of this wiring, I wouldn't have that advantage of judging where they go based on wire length. They're definitely not as clear. So I don't know, this last one doesn't want to go on. There. 1, 2, 3 little soldiers there. Now you say danger. Okay. All right. Now these. Okay. Have to make sure they actually slide on properly and not just into the insulation sleeve. These ones I kind of separated manually before taking them off so that it'd be easier to tell where they went, you know, kind of push them to the side. That one seems to have shifted a bit. All right. Now these ones. Tricky, tricky, tricky. Let's see. We got quite a few there. We got these two as well, and we got two back there, which are probably these two, but which one's which? The top one, the uppermost, I'm looking at the picture, goes to the one behind, so this is the uppermost, so that makes sense. Alright, and then for the other ones, oh, that's tricky. Where do they even go? Kind of twisted. So these have to go under here for starters. And then, can I tell from that? I really can't. That one seems to want to go up, that one seems to want to go down. Kind of makes sense. I mean, I guess the standby switch doesn't matter which way they go in the end, I would think. Okay, so now we got those, which is red. I think I have another picture. Just have to check. I mean, you all want to take as many pictures as possible, and then you realize you probably should have taken more most times. Okay, so we're looking at, yeah, this one's right. And then what is going on there? We're looking at white, red bottom like that, and black the other side. So we'll do the bottom ones first, which is red down there. Apologies if I get any hair in the camera. We'll get some pliers in there for that one. It's a bit tight to get my hand down in there. Okay. There we go. And we're looking at white and red. Oop. Okay, all of those look to be in. Now try to check to see if I've missed any, and then we'll put some screws in and we'll see if she fires up. Where are the screws? Alright, we've got some screws here. We've got a little magnetic screw holder. I'm really only concerned about one of these. Hopefully I didn't just hear something drop. I don't think so. Down in there's one with a star washer. That the others don't have that, so that would indicate to me that this is some sort of grounding screw. So we definitely want that in for testing. Great. Okay, just move that star washer over. I don't know how it shifted. Well, it's kind of stuck in the hole. That's why it moved a bit. Just kind of curious why it didn't come off. You know what? Maybe we'll put you right on the screw. Although now I got to get both of them in proper. Maybe that wasn't a good idea. Let's try it like this. Isn't it great when the magnets work against you? They hold on to a component when you're trying to let go. Okay. That looks pretty good if I can get it to stay there. And get the screwdriver in. Alright. Make sure some of these other screw holes are lined up, even though it doesn't look like they're grounded. Okay, that's nice and tight. The input is also grounded, so I kind of want to put that on as well if I'm going to test. There. I've got these little 3D printed sockets, although they kind of stripped on some of these because the pots were mounted so tight. Alright, I'm going to probably pause so I can set up a speaker, plug this in, and we'll give it a test. Okay, we've got power plugged in, we've got an 8 ohm speaker plugged in, we've got this V1 tube back in. I just want to do kind of a once over, see if I've missed anything. I'm not seeing any loose leads, so hopefully that means I'm good to go. Feeling optimistic. Let's knock on wood. I've got my SG here, it's plugged in. So we're going to power it up, see what happens. We're on standby and powering on. Got light. I hear some crackling. Just gentle. So we got master down. We're going to switch to play. Some sort of buzz, but that doesn't sound like a proper signal, and I'm not getting any signal through. Controls don't seem to have any effect. So I'm going to go ahead and power down, and we'll get back to investigating. So I'm back just a minute later as I was looking over this in dismay, trying to figure out what I have to do next. I noticed that the power connector spade seemed a little loose, and sure enough, the ground, when I went to kind of see if it could push on further, just popped right out of the power socket. I think it's called IEC connectors. So I'm guessing that's maybe a likely culprit for something. So I'll go ahead and try to sort that out. And I'm not quite sure how at this point. But after that, we'll see if it powers on. Okay, taking out the IEC connector, and sure enough, I mean, this lead or this terminal was off. They're kind of crimped in place with the little rivet style things. So I put it back on and I soldered it in place. You can't, you gotta be really careful soldering here because you're gonna melt the plastic. So I'm hoping this will be enough to stay. This is pretty accessible, so if something fails, I'll be able to get back in here and replace this or repair it again. So I'm going to put this back together, and we'll see if that solves our issues. Okay, so we've got the IEC connector back in, we've got speaker plugged in, we've got power plugged in. We're going to give it another try. That's not, the power is not plugged into the wall. So, good safety by me, but bad hooking back up. Okay, here we go again. Got a power light. Nothing catastrophic so far, knock on wood. I'm going to take it off standby. That's another kind of nasty hum. So I don't think things are solved just yet. Controls don't seem to matter. Not sure what things are at this point. Back to square one, square two. Not sure. but we'll look into it. Alright, I did find one error I made when I was reassembling, which was reversing these two leads, this red and this black, OC14 and how do I see in there, an OC5. So I'd swapped those. I went and checked my reference pictures and realized that those were off. So just for completeness sake, I've swapped those back, but it hasn't changed the behavior of the amp. I still have power plugged in. I still have the speaker plugged in. So just so you see, I'll give it another try turning it on. But I've already done this, and it ends up with the same behavior, but just so, like I said, for completeness sake, we're on standby now. I'm going to turn it on. I've got power, and we get what sounds like, to me, an AC hum on the speaker. We get like a, but you'll see in a second as I turn it on. And there you have it. I'm not going to leave it on too long because I don't want to fry anything else. So that's the current behavior right now. I'm going to ask around and do some checking here and formulate a plan of attack to move forward, and then hopefully I'll be posting a follow-up video with this amp working, maybe some more work I'm doing on it. We'll have to see. But thanks for watching. We'll catch you next time.